All right, guys, so a quick review of inverse functions before we get into the derivatives of inverse functions. So remember, an inverse function basically takes the outputs and reverts them into inputs to get back to where you started. So if I plug in, for example, x squared, my inputs, if I put in 1, 2, and 3, I get out 1, 4, and 9. So the inverse of x squared, my inverse function, would go the other way around. It would make it so when I plug in 1, 4, and 9, I get out 1, 2, and 3. So an inverse function kind of undoes the original function. And really, it's just a reflection. If you look at the graph, it's a reflection over the y equals x, which means your ordered pairs just get switched. So your 1, 1 becomes, 1, 1 in our example here. And your 2, 4 becomes 4, 2, and so on and so forth. So really, you're just exchanging your x and your y's with each other. So what that means is the domain of your original function becomes the range of your inverse and the other way around. Your x's become your y's become your x's. And that's really how you find your inverse. The way that you were taught to do it was to switch your x and y and solve for y to get your inverse function. Couple things about the existence. For an inverse function to exist, it has to pass the horizontal line test. So for example, my x squared, the problem with my x squared function is if I draw a horizontal line, I hit my function in two different places. And that becomes a problem because the inverse of this function would actually look like this. It's like a sideways parabola. The problem is this isn't a function because it doesn't pass the horizontal or the vertical line test. So what you have to do is you have to restrict your domain. So basically what you would say on your original function is that your x's have to go from 0 to infinity. So in this case, now your y's would go from 0 to infinity. And these wouldn't exist anymore. Your domain becomes your range becomes your domain. So putting this into practice a little bit, just a couple of guidelines for finding the inverse. The first thing you need to do is determine, does it even exist? Does it pass that horizontal line test? And if so, you solve for x as a function of y. So you switch your x and your y, and then you redefine your domain and range. So for example, finding the inverse of f of x equals root 1/2 x plus 2. First of all, we need to know what it looks like. Now, without getting too specific, this is a square root function, so we know it's going to look something like this, right? So that means it's going to pass my horizontal line test. Anywhere I draw a horizontal line, it's only going to go through my function one time. So I know that it exists. Now I just need to solve for it. So the way that you learned to do that was our original function is y equals root 1/2 x plus 2. So we taught you to switch the x and the y. So to put the x over here and set that equal to the root of 1/2 y plus 2. And now we try to get y by itself. So to do that, I'm going to square both sides. So I get x squared equals 1/2 y plus 2. And to get my y by itself, I'm going to minus 2 from both sides. So x squared minus 2 equals 1/2 y. And to get rid of the 1/2, I multiply both sides by 2. I multiply by the reciprocal. So I end up with 2 times x squared minus 2 is equal to y. And if I want to, I can distribute that 2, which I probably should. And let's go ahead and put the y on the other side. So I get y equals 2x squared minus 4. So what this really is saying is it's not really y, it's actually f inverse of x. The inverse of my original function is equal to 2x squared minus 4. So anything I put into this function is going to come out, and they're going to switch places. So my inputs here are going to become my outputs, and my outputs from this function are going to become my inputs. So looking at this function right here, that's going to look like kind of like a parabola, right? And that the problem there is my original function looked just like a root function. So I have too much going on with this one, which is because my domain and my range, when I squared both sides, my range got too big. So what I have to do is limit what I can put into this. So here, if you notice, your inputs stop at 0. Okay, so here your domain just goes from 0 to infinity. It goes from 0 to the right as much as it can. So on this one, what that means is that your range is going to go from 0 to infinity. But also looking at your outputs, here my range looking at my up and down, my range goes from 0, that's my lowest point, and it goes up to infinity. So that range becomes my new domain down here. Since my outputs go from 0 to infinity, that means that my inputs, my domain, has to go from 0 to infinity. Or in other words, I can't have any x's over here. I can only have my x's starting at 0 for my inverse function, okay? Moving on, enough of the old stuff. So what if we're trying to take the derivative of an inverse? So what if I'm trying to take the derivative of f inverse of x? At this point, x equals 4. So the first thing I have is my function, f of x equals x squared, for all my x's greater than or equal to 0. So that's just telling me that I'm not using the whole parabola. I'm just using my parabola when x is greater than or equal to 0. Okay, and there's a few methods to do this. One of those is to go ahead and find the inverse function, solve for y, and then find the derivative of the inverse function. So I could do that. I could say, all right, so y equals x squared is my function. Now I've got to swap. I've got to put my x over here equals y squared. And now I want to get y by itself. So I'm going to take the square root of both sides. So the square root of x is going to equal y, which really just says my f inverse of x is equal to the square root of x. Now I can go ahead and take the derivative of this. I can take the derivative of both sides. So I end up with f inverse of x. And you have to be careful here because what we're actually doing is taking the f inverse prime, right? We're taking the derivative of the inverse. So be careful with your notation. And when I take the derivative of root x, remember we like to write that as x to the 1/2. So I just get 1/2 x to the negative 1/2, which becomes 1 over 2 root x. And I mean, we've done this one 100 times. I'll let you go ahead and work out the algebra there if you need to. But the derivative of my inverse, so my inverse f inverse derivative is equal to 1 over 2 root x. And it wants me to take that at 4. So I go ahead and plug 4 into this function. So I get 1 over 2 root 4, which equals 1 over 2 times 2, which is just 1 over 4. So at the point 4, my derivative is going to be 1/4 of my inverse, okay? Now, that's one way to do it. I don't really like to do it that way. I don't like to do it the second way either. What I usually do, because the inverse is just the reciprocal, I can say that, you know what, f of x has a point of something 4, because what we're looking at is it wants x equals 4 of my inverse. Whoops. It wants x equals 4 of my inverse. So I have to be careful. I'm looking at when x equals 4 of my inverse, which means my original function is going to have an output of 4. So what I'm looking at is, what do I plug in my original function, x squared, to get 4? Well, I plug in a 2. When I plug in a 2, I get 2 squared equals 4. So what that means about my inverse is when I plug in a 4, I should get out a 2. Okay, so we got to be really careful that we don't plug the 4 into the original function. We plug the 4 into the inverse. And then to find the slope, I just take my derivative. So my original function is x squared. So if I have f of x equals x squared, when I take the derivative, that just becomes 2x, right? So f prime of x is equal to 2x. And so to find my slope, I plug 2 in at that point. 2 times x is 2 times 2, which equals 4. So my slope at this point is 4, which means my slope at the inverse, instead of 2, 4, my slope at 4, 2 is going to be the reciprocal. It's going to be 1/4. Okay? So not only do the points swap, right? My 2, 4 becomes 4, 2, but my slope also is the reciprocal. All right, so let's try a few of these, because that was just a lot of rambling, and let's look at from start to finish in just one method. I'm going to use that method 3. Okay, I like that method a little bit better. X cubed plus 4x minus 2, and it wants us to find the derivative when the inverse of x is at x equals 3. So I've got my original function and I've got my inverse function. Okay. Now I'm looking for my inverse when x is equal to 3, and I don't know what my y is yet. But what I know is if my x is 3 for my inverse, my y is 3 for my original function. So that's a little bit more complicated, because what do I plug into this original function to get an output of 3? There's a few different ways that we can do that. I mean, you can go ahead and solve that and try and figure it that way, but I'm just going to use my calculator. I'm going to go ahead and just plug in x cubed, so x to the third power, plus 4x minus 2. And I don't just want to graph that, because I want to know when is my graph going to be 3. So I'm going to graph both of those. I'm going to graph, here's my original x cubed plus 4x minus 2. That's the blue one. The red one is when x is equal to, or when y is equal to 3. So the point I'm interested in is this point right here, when y equals 3. So I could use the table. I could just kind of trace and guess, I think that's at about, it looks like it's at around 1 when x is equal to 1, but I'm not sure. So one thing I can do is second calculate, and I can just find the intersection of those points. So what I do is I just get close to that point, and I hit enter, enter, enter. And it tells me that they do cross when x is 1, y is 3. So what that tells me is in my original function, I get an output of 3 when I put 1 into it. So my inverse function is the opposite. When I put a 3, I get a 1 out. Okay. So what we're looking for here is I've got my point. What I need now is my derivative. I need my slope at this point. So I'm going to go ahead and take the derivative of f. So f prime is going to equal x cubed, just becomes 3x squared, plus 4, and that negative 2, just that minus 2 goes away. So I get 3x squared plus 4 is my derivative of my original function. So what I need to know is what's my slope at this point right here, 1, 3. Not 3, 1. I'm working with my original function 1, 3. So I'm going to go ahead and find f prime of 1 equals 3 times 1 squared plus 4, which is going to equal 3 plus 4, which is just going to equal 7. Okay. So if my function, if the slope at 1, 3 is 7, then my inverse function at 3, 1 is the reciprocal of that. So the inverse derivative is going to be 1 over 7 at that same point. Okay, so my derivative at x equals 3 of my inverse function is just 1/7. Okay. So looking at if f of x equals x plus sine of x, find the derivative. We're going to use the same method, f of x, and we're going to use our f inverse of x. So when f of x we're looking for when x equals pi of our inverse function. So that means I'm looking for pi, for my y value to be pi. So my x value from my inverse is my y value from my regular function. Now we've got to be careful. We can do the same thing we did before. We just got to make sure on our mode, we want to go down and change we want to make sure that we are working in radians. And then I just go to y equals and I plug in x plus sine of x. And I also want to graph when y is equal to pi, because I'm looking for where these two cross. So I'm going to go ahead and put in when y is equal to pi. So I graph that. There's my x plus sine of x is that weird crazy curve. And then when y is equal to pi, I'm looking for this intersection right here, which looks like it happens, at 1, 2, 3, somewhere between 3 and 4. So rather than guess, I'm going to calculate what's the intersection? When does that point exist? So I go ahead and just, let's get close to it. It's somewhere right here, and I hit enter 3 times. And it says that when y is pi, x is pi. So that just tells me that my input is also pi, which means my inverse, my output, is going to be pi. My x's become my y's become my x's. So we've got our point. Let's look at the derivative. So if f of x is equal to x plus sine of x, then I want to know what's f prime. So f prime of x is going to equal, well, the derivative of x is just 1. The derivative of sine x is cosine of x. So there's my derivative, but we've got to plug in our pi. So f prime of pi equals 1 plus the cosine of pi. Well, 1 plus the cosine of pi is 1 plus cosine of pi is -1. So my slope is actually 0. At pi, my slope, m, is going to be 0, which means with my inverse function, at the inverse point at the pi, my slope is going to be the reciprocal of 0, which is not 0, guys. The reciprocal of 0, so 0 is 0 over something. The reciprocal of that is 1 over 0, which is not 0. It does not exist. Okay, so my derivative at x equals pi does not exist. And if you look at the picture down here, at pi, at my 3.14, my original function, my derivative was 0 because I had this horizontal point right here, right? So my tangent line was a horizontal line, so I had a slope of 0. But the reciprocal of that horizontal point is vertical. Well, if my tangent line is vertical, I don't have a slope. It does not exist because it goes straight up and down. Okay. And you can always check that on the calculator if you need to. If you need to go ahead and plug those in to double check, you're welcome to. But let's just keep moving on here so we don't get a video too long. So a couple of things to remember about continuity and being differentiable. Okay. First of all, to be differentiable, it has to be continuous. Okay. Our function has to be continuous. It can't have, which means it can't have any, we can't have any sharp points. We can in the graph, but to be differentiable at a point, it can't be a sharp point. The rest of the whole function can be differentiable, but to be differential at a point, it has to be continuous, and it can't have any sharp points at the point that we're trying to differentiate. Okay, so a few different forms of, I guess, just a few different ways that we write this same stuff. It says that if G is the inverse of F, then G prime of X equals 1 over F prime of G of X. And I don't ever write it this way just because it's a lot to wrap your head around. But basically what it's saying is just that the derivative of our inverse is the reciprocal of our original function. So if f of x, if the point AB for f of x, the derivative for G at B, at that point, the derivative at B is 1 over our original function's derivative at A. Okay, which is what we just did. Okay, the derivative of our function at 1, or when x equals 3, was the derivative of our original function when our output was 3. Okay, so all that means is going forward. Let's just do a problem here. Question 3, this is an actual AP question, and I believe it's from 2007. And we're not going to be able to solve the whole thing. In fact, it gives you a bunch of information, then it says, explain why there must be a value R for 1 less than R less than 3. We haven't learned that yet. We haven't learned how to explain why there must be a value C. That's the mean value theorem. We haven't got there yet. And even C, we haven't done integrals at all. So A, B, and C, you couldn't answer on the AP test if you tried at this point. But part D says if G inverse is the inverse of G, then write an equation for the line that's tangent to the graph at G inverse of X at the point X equals 2. So even though you can't do A, B, and C, this is asking you to write an equation for a tangent line for the inverse of G, which is something that that's something that we can actually do. So remember, to write a tangent line, to write to come up with the equation of a tangent line, we need a couple of things. We need a point and we need a slope. Okay, so we're going to and we use the derivative to find the slope. So it wants us to find the tangent line for the inverse function when x is equal to 2. So what we're going to do is we're going to just go with what we did before. We're going to look at G of X, and we're going to look at G prime, or G inverse, the inverse of G at X. And it wants us to know, well, when X is equal to 2 for our inverse, which means our original function, if X is equal to 2, that's when our Y is equal to 2 for our original function. So if I look up at this table that it gives me, I want to know what X input gives me an output of 2 for my G function. So if I look at my G function, I get an output of 2 right here, which means my input is 1. So I'm going to have an input of 1 is going to give me an output of 2, which should match my inverse. So what that means is if I put a 2 in my inverse, I should get out a 1. So I've got my point. My point is 2, 1. Now I need to find the slope at that point. So what I'm looking for here in my original function is the slope at 1. And that's going to be the reciprocal for my slope of my inverse function at 2. So my slope at 1 of g means I need to look at g prime. G prime is right here. And if I put a 1 into g prime, if I put a 1, I get out a 5. So what that means is my slope at 1 for my original function, my slope at 1 is 5. So for my inverse function, if my slope at 1 is 5, then at 2, when x equals 2 of my inverse function, my slope is going to be the reciprocal of 5. It's going to be 1/5. Okay? So my tangent line, my equation for my tangent line, remember we get y minus y1 equals the slope at x minus x1. So I'm using this point and this slope, not the other way around, because I'm using my inverse function. So y minus 1 equals 1/5 x minus 2. And that right there, I wouldn't even solve it. I would leave that as my answer right there as my tangent line. Okay. So if I were to look at the scoring rubric for this, again, we didn't earn any points on 2. In fact, on all the free response questions, you can earn 9 points. Okay. So on this question, you would lose the 2 points for A, you would lose the 2 points for B because we didn't even do them, and you would lose the 2 points for C, but there's 3 points available on part D. Okay, so it says that you would earn 1 point for finding the inverse, finding the inverse at 2. Okay, which we did, right? We found the point, the inverse of 2. Right here, we said, well, g inverse of 2 is, our point is 1. So you would have got 1 point right there. We would get a point for saying that at the derivative at the inverse of 2, for basically finding the slope at the inverse, is the reciprocal of the inverse at 1. So here we found that the slope is 2 because the slope at 1 is 5. So the slope of our inverse at 2 would be 1/5. So you'd have gotten a point right there. And then you would have gotten a point for the tangent line equation. And if you notice, they used the same, they didn't simplify it either. An equation of the tangent line is y minus 1 equals 1/5 x minus 2, which is right where we stopped. Okay, so they would have done it the same way that we did it there. Okay, so homework, that leaves you to homework for 2.6. The one thing you need to be really careful of, what's going to happen is when it tells you to find let's go back here, the derivative of the inverse at x equals pi or x equals 3. Remember, it's talking about the x of the inverse, which is your y of the original function. So make sure when it says to find it x equals 3, if your x value is 3 for your inverse, that means your y value is 3 for the original function. Other than that, you should be okay for 2.6.